Mindsetters, welcome to your grade 12 maths lesson on a Monday. I am Luni and with me is Tamala.
Hi, Luni. Hi guys, how are you?
We're good. How are you doing, Tamala?
Very, very well today. Thanks so much.
Alright, what are we doing for the matrics today?
Today we are doing statistics, which is a section which has a lot of carry through from grade 11 and even grade 10. But what's really interesting about stats in grade 12 this year is there's quite a lot of new stuff that they've added to the syllabus with regards to lines of regression and correlation coefficients, and they all sound very interesting, but they're actually quite easy to work out.
Alright, Mindsetters, I hope you guys are excited for the lesson and you'll be tuned in. Just to tell you about a competition we have running, it's called Get Connected. All you need to do is go to our Facebook page. All the information is there, but I'll take you step by step through what you need to do in order to stand a chance to win either Vodacom Airtime or a Sony Xperia L. So you go to our Facebook page, there's a link there with capital letters Learn. What you do is you click on that link, it'll take you to your Curio page, you enter the Learn code, and then you pick your favorite teacher. The various teachers there, you pick your favorite teacher. After you've done that, you go back to our Facebook page. There are links with the teacher's name. So if you chose Camelin, you go to /Camelin. You click on that link, it will take you to a picture of that teacher. You like that picture. And then once you've liked that picture, you go back to the graphic with all the information about the competition and you share that post. Once you've done that, you'll stand a chance to win airtime. All the people who've shared the post will stand a chance to win airtime. All the people who've liked the teacher with the most likes will be sent through a lucky draw to stand a chance to win a Sony Xperia L. Right now, we are going to do a lucky draw for the winner for the airtime. Tamerlane, are you ready?
Wow, that's exciting.
Okay, so I'm going to shake this box. Okay.
No, not to look. There we go.
Important. See, you have won yourself Vodacom Airtime.
That's awesome. Well done.
Simple as that, Mindsetters. While I'm here, facebook.com/LearnExtra is our Facebook page. @LearnExtra is our Twitter handle. And you can get all the videos, the show notes, and the schedules on learn.mindset.co.za. Tamerlane.
Thank you so much. All right, guys, so let's get going with our stats. If you guys haven't started with stats in school yet, you're going to be doing it very soon. And as I said, a section which has a lot of carry through from grade 10 and 11 work. So you do need to get out those old books. You do need to study all of that theory. And then obviously we're going to add to it today with our regression and correlations. Okay. All right, guys, so let's just very quickly look at what we're doing today. We're going to first just have a look at those grade 11 concepts. I'm not going to spend too much time in terms of actually teaching it, but we will discuss it briefly. And then we're going to look at these new concepts, which are scatter plots, lines of best fit, which is just another word for the line of regression, something called interpolation and extrapolation, and correlation coefficients. Now, I know that possibly all those words look quite large and a little bit daunting at the moment, but with explanation, I'm sure you're going to understand them perfectly fine. And then lastly, obviously, our examples that we're going to do to explain and obviously just clarify all of those concepts for you. Okay, so we've got a challenge question, which without having done the exercises just yet might look a little bit strange, but I want you to take it down. I want you to take note of it. And as we're going through the exercises, see if you can then actually give this a go, and at the end we'll have a see on how you manage, okay? We've got a men's shoe store conducts a survey from a representative sample of regular customers to see ages of customers against the amount they spend monthly on shoes. Okay, so we've got this table. So very quickly, age of customer, if I've got 18 years old, they're spending about 330 Rand on shoes, 21 years old, 300 Rand on shoes, and so on, okay. First things you're going to do is you're going to use your calculator to determine the regression line which best fits the given data. Okay, so take notes of that, guys, because I'm going to teach you how to do that shortly, is how to find that equation that represents the line of best fit, okay? Once we've done that, we're going to determine the correlation coefficient for the data set. Okay, now again, I know that that sounds a little bit of a daunting phrase at the moment, correlation coefficient. Remember the word correlation. If anything at the moment, think about what I'm talking about when I talk about correlation. How are they related to each other? Are they closely related? As one of them increases, does the other one increase? Remember that that represents a positive correlation. Or as one increases, does the other decrease which would represent a negative correlation, okay? So that's what we're talking about with regards to correlation coefficients. Then we're going to predict how much money a 16-year-old will spend on the shoes at the store. Now, on your table, and you'll see on the notes, remember we started with only 18-year-olds. That was our starting point. So 16-year-olds are not actually on that table of data that we were given. So the point of this line of regression is that we can actually now use that to predict information not just given in our set of values, okay? And finally, we can decide whether our prediction in the question is reliable or not. That's got to do with such values as outliers, and are we actually looking at a value that's reasonable and actually probable in that data set. Okay. All right. Okay, so some summary. This is quite a detailed summary. It is in your notes, and I want you to go back and have a look at it, guys. I'm going to go through them briefly, but as I said, I'm not going to reteach all of this stuff. You should know it at this point. It's just to go over it and remind you, okay? All right, so we've got our measures of central tendency. We've got our mode. Remember, your mode is your most common value in your data set, okay? Your median, remember a way of referring to your median is your Q2, which is your middle value. This is important of your ordered data set. Remember, to find your median, your data is always going to be arranged from smallest to biggest, and then you find your middle value, okay? Your mean, remember the notation for the mean, which is at x bar, is the average of your data set. And remember, to calculate your average, you're taking the sum of all the numbers in that data set and you're dividing it by how many numbers were actually there. Okay? Right, so that is our measures of central tendency. 5-number summary. Okay, I hope that the second you see that 5-number summary, what jumps to your mind is box and whisker plots. Remember that in order to do a box and whisker plot, you need to first have that 5-number summary. So very quickly having a look at that, your 5-number summary consists of the following. You need the minimum value in your data set. You need your lower quartile. Now remember, if you've got a set of ordered data, you've got your lowest number, you've got your highest number. The middle number, that's your median, and remember we call that Q2. Now your median has divided your data basically into 2 halves. So to find your lower quartile, you're going to take the first half of your data and find the halfway mark of that. Okay, that's giving you Q1, and your upper quartile is your halfway mark of your upper half of the data. Okay, so your 5-number summary was your minimum, your lower quartile, the middle number, your median, your upper quartile, and the maximum number. Okay, and remember, as I've already mentioned, that's the data, the information that you need in order to plot your box and whisker diagrams. Okay. Measures of dispersion, how the data is spread. Okay. We talk about the range. All right. The range is essentially just the difference between the highest and the lowest value in that data set. Okay. So that's your range. The interquartile range, all right, that's the difference between your upper quartile and your lower quartile, all right? So your difference between your Q3 and your Q1. That's the interquartile range. Calculation of the mean, all right, I have already mentioned this, but just in terms of a formula, just take notes of this, guys. Here it is over here. To calculate your mean, always take the sum of the values in your data set and divide it by the number of elements in the data set. If you want to work out the average age of pupils in your class, you're going to add everybody's age together and you're going to divide it by 28 pupils or however many are in your class, and that will give you your average. Okay? Remember to be careful of outliers when you work with average. If you have a teacher who's much older than the class, who probably is, okay, then what we're going to do is, if we included the teacher's age as part of the average, you remember that would actually increase your average and actually skew the data. So you've got to be careful of outliers, because that can actually skew your reading quite substantially. Ogives, remember your ogive is the graphic representation of your cumulative frequency, okay? Your ogive graph is normally in the shape of an S. It's normally that S shape, all right? And just remember, when you're plotting your ogive graphs, that you don't do it with straight lines. You actually do it as a smooth curve, okay? So you don't use a ruler plotting one point to the next to the next. we do it as a smooth curve. All right. Okay. What else do we have? Okay, just some more grade 11 revision, our variance and our standard deviation. Standard deviation, grade 12, just remember, is the average deviation from your mean, okay? So if we have a very small deviation from your mean, then what we know is the data is very consistent, okay? If we have a very large standard deviation, it means that the deviation from your mean is quite inconsistent. There's a big deviation from the average, okay? So if we have a class who's written a test and everybody got very much around, let's say the average, which was 55%, and the marks were all very much clumped around that 55%, we're going to have a very low standard deviation. But if we have a test where the average might be 55%, but you had some people getting 98 and you had some people getting 23, although the average is still 55%, the standard deviation is showing that it's much more inconsistent results. Okay. The formula for your standard deviation is the sum, okay, of all your individual values minus the mean squared divided by the total number of values, all square rooted. Okay, as I said, guys, I'm not going to go into detail with that today. Hopefully you have done it in grade 11. Hopefully you've had time to actually revise that at this point. And if not, please go over that. It's important that you do revise that yourselves, okay? All right, and that kind of, that does lead us to the new information that we're going to learn this year with regards to statistics. Okay, so all of that stuff that I've just mentioned, that is going to be there in your exam, so you must make sure you study that. Together with this, we're going to talk about scatter plots, okay? Now, we take two pieces of information, the temperature of the weather in the month of, let's say, September, and the sales of cold drinks at the tuck shop, okay? We've taken these two pieces of information and we want to try and establish what kind of correlation there might be between the increase in temperature as the temperatures rise as we go into spring, and the sales of cold drinks at the tuck shop. As the temperatures increase, do the sales of the cold drinks increase? Is there a positive correlation there? Now remember that scatter plot is going to be the graphic representation of that correlation, all right? And a scatter plot is basically going to have three different, we're either going to have a correlation which is going to be positive, in which case all the points are going to be very closely grouped together. Let's just quickly show you a quick diagram, but we'll do these in detail now. Okay, a diagram, if it's looking like this, it looks like we're going to have all the points very closely grouped together, and they almost look linear, not 100% linear, but they look linear in a positive direction. So that scatter plot would be representing a positive correlation between the increase in temperature and the increase in the sales of cold drinks, as an example, all right? A negative correlation, which would be represented in the other direction, so a negative linear correlation, okay, would look something like that. And all the points are very closely grouped together, and that would represent a linear negative linear correlation, okay. The line of best fit, okay, so now least squares regression line, okay, you may hear that in class, your least squares regression line, and I'll explain to you in a little bit more detail what we mean by least squares regression. But we're going to refer to it as a line of best fit, okay? And essentially a line of best fit, again, I'm going to do this in detail in a minute, but a line of best fit is the line which, as we draw it through the points on your scatter plot, it most accurately represents the middle path of the data, okay? And it would sort of give you your most generalized representation of those points over there. Okay, so your line of best fit, and we can get an equation for that line of best fit, which I'm going to show you in a minute to do. All right, and then lastly, your correlation coefficient. We want to determine, and we can actually do this mathematically, how close is the correlation? Is there a 100% correlation between as the temperature increases by every 1 degree in increase in temperature, 10 cold drinks get sold and there's no variation on that? If that was the case, we would have a 100% positive correlation. Obviously, temperature and cold drinks, there's a little bit of variation there. However, the correlation would be relatively strongly positive that as the temperature increases, so the sale of cold drinks will increase. Okay, so we work out mathematically in terms of a number, the representation of the correlation. So let me actually quickly talk about that. With correlation, we basically span from a value of -1 to +1, okay? And we have 0.5 in the middle of those, all right? -1 is a perfectly, in fact, sorry, I should actually put this the other way around because it's going from greatest to smallest. A +1 represents a perfect positive correlation. It is an exact increase from one to the next. Anything ranging from +1 to 0.5 is going to be obviously ranging from 0.6, 0.7. As it gets increasing to 0.8, 0.9, so the strength of the correlation will increase. But anything there will represent a moderate to a strong to a perfect correlation, all right? And anything varying between 0.5 and -1, sorry, actually just 0, not 0.5, sorry. Let me take that away, it's just 0. Okay, obviously 0 representing no correlation, okay. Anything from 0 to -1 would then give us a moderate to a strong to then a perfect negative correlation, okay. So that's what we're going to be working out in terms of an actual value. So let's give ourselves a few examples and let's see if we can put all of this into practice. Okay. I think before we do, maybe it's time to just take a very quick break. You guys can get all your notepads and rulers, and please get your calculators out. You are going to need them, and I'm sure we'll be back shortly.
All right. Mindsetters, some of you are saying that you have a problem with the MoMaths website. You need to go to momaths.nokia.com/ZA. It will take you to a page. I've posted what the page looks like on our Facebook page. It will take you to the page where you have to register, and then you can start practicing your maths and improving your skills. I've posted all the information on our Facebook page. Check it out, and then you can start challenging other mindsetters as well. Let's take a very quick break, and I'll see you straight after this. Welcome back, Mindsetters, from that break. It's part 2 of our draw for the Get Connected competition. So, Tamerlane. And the winner is Nzovo Paul Baloyi. Well done. You have won yourself airtime from Vodacom. 55 Rand airtime from Vodacom. Get connected, guys. Enter the competition. All the details on our Facebook page. Tamerlane!
Well done. Okay, right. So you're all sitting with your calculators in front of you. You've all got pens and papers, and let's get going. And a ruler. You need a ruler as well. Okay. Okay, we have got a table below which represents the distance in meters required by a car to apply brakes and reach a standstill when it's traveling at a given speed. Okay, so traveling at 20 kilometers per hour, we are going to require 6 meters of braking distance. 40 kilometers per hour, 16 meters, and so on, 60, 30, and so on. Okay. All right. Draw a scatter plot to represent this data. Okay, so let's have a look. We are going to use our x values as our independent variables. So remember, that's going to be your horizontal axis, and these are going to be our dependent y variables, which is your vertical axis. Okay, I've drawn a I've drawn an x and a y axis over here. Please take note of the fact that I have labeled my axes. Okay, grade 12, you don't want to go and lose unnecessary marks by not labeling axes. So please make sure that you've labeled your horizontal axis as your speed, if you want to write in kilometers per hour. Okay, let's be specific. And the vertical axis is your braking distance. Okay, right, so let's plot. We're going to have to go back and forth a little bit, so just bear with me. 20 was 6 and 40 is 16. So 20 is at 6, which is around about there. 40 was at 16. So we're going to have to, if you want to use a sort of a guideline, let's see. So 16, we're going to have to estimate probably about over here. And that's to 40. So there's our point. Okay. All right. What was our next two? We had 60 and 30, 80 and 48. So 60 and 30. 60 and 30. All right. Alrighty. And we had 80 and 48. So 48, let's put 48. It's an estimate, but there we go. 48's about there. All right. So there's our 2 points. You've got another point here and another point over here. And we have got, okay, so we've done 80, we've got 100, and we've got 70. I've got 120 and 80. So 170, 100, 100. Oh, we've changed our color. And 70 all the way across over there. And we had, now I've gone and forgotten, 120 and 80. 120 all the way up to 80, okay, and lastly we've got, it was 140 and 110. 140 up to 110. Okay. All right, so these dotted lines here are just a guide. You don't have to do those, but just with the ruler, just use it as a guide to help you to get that correct, okay. All right, so there we go. We've got our points, we've plotted our points. I hope you can see that as per my sort of example in the previous, in my summary, we can see that this looks like a fairly strong correlation, a positive correlation, that the faster you're going, the greater the speed, the braking distance is going to be. So it looks very much like it's a very strong linear correlation over here. Let's just see what they're asking of us. So we have, oh no, we're going in the wrong direction. Right, so draw the scatter plot. We've done that. Explain whether it's linear, quadratic, or exponential curve. Well, the line of best fit, if I were to draw a line passing through as many of the points as accurately as possible, trying to leave as many on the top as you've got on underneath the line, I think we all agree it's going to be a linear. Okay, so we've got a linear line of best fit over here. Okay, so that's question number 2. Determine the equation of the regression line. Okay, so the line of best fit is very much an estimate. You know, we're going to estimate where this line is passing through. But this line is represented by an equation, all right? So we can actually work out the equation of this line of best fit, and we can do it by means of using your calculator. All right, so grab out your calculators, and this is what we're going to do. We need the data in front of us. And we are going to, I'm just going to shift that over. Right, are we all watching carefully? The first thing we're going to have to do is say mode and then press 2 for stat. Okay, so we've got that on our calculator. And the button that we need to press to get this linear line of regression is button number 2. Okay, it's the A plus BX button. That's the formula for a linear equation. Okay. All right, so now what we do is we've got all of this information over here, which we're going to have to plug into the calculator. So I'm going to say 20 equals. I've got 40 equals. I've got 60 equals. 80 equals. 100 equals. 120 equals. And 140 equals. Right, so I hope you guys have got all of that in your calculator. Where to from here? This is the sequence of buttons that you need to press. You're going to press your AC, Shift 1. All right? AC, Shift 1, which now brings up a screen of the following 1 type, 3 sum, 5 reg, and so on. We're doing the regression line, so we are interested in number 5. Okay, that's the one that we need to press. So we're going to press 5 for regression. And now if we look at the button, if I press 1, I'm going to get the value for A in my linear equation, and 2 is going to give me my value for B, all right? So let's press 1 equals, and, oh dear. Let's see, AC Shift 1, let's go back to there. 1 equals, no. Okay, let me quickly type in the values again so that it's, okay, let's try again quickly. 2. All right, we had 20. We've got 40. I've got 60. Oh, guys, I know what I did wrong. 60, 80, 100. I've got 120. And I've got 140. Sorry, the mistake that was made there is I need to fill in the other side as well. Calculator can't work out the values unless it actually has the values. Okay, so on the other side, on the y values, we have got a 6, we have got 16, we've got 30, we have got 48. We've got 70, 80, 80, and 110 equals. Okay, right. Okay, sorry. So now we've got all our data into our calculator. Now let's remember. Remember, AC shift 1. So AC shift 1. We press 5 for regression, and the first value I need to know is the A, so we press A equals, and we get a negative 17,1428. A equals negative 17,1428. I'm just going to keep that over there for now. Then we go back to saying AC shift 1 again. It gets me back to the screen where I need to press 5. And the other variable we needed to know is the B, which is number 2. So we say 2 equals, and we get a 0,8571. 0,8571. Okay. Now remember, on the calculator, the equation said A plus BX. That was the equation that we are working out over there. So in terms of the linear equation that we're familiar with, okay, we are familiar with it being in the form of y equals mx plus c. That's kind of the equation that we know as a straight line graph. So what I would suggest is let's just rearrange it. So if I said y equals bx plus a, does that make a little bit more sense in terms of the linear equation? Okay. The b represents 0, so let's just change color here. So therefore the equation that we're looking for is y equals the b, which is actually the gradient of your line. That's your 0,8571 x minus 17,1428. So the negative 17,1428, that would represent, if you remember your theory on straight line graphs, that would represent your y-intercept. Okay. So if I were to continue drawing, if I were to draw a straight line, and it were to carry on down, it probably would intersect. Let's get rid of that. It probably would intersect the y-axis at about negative 17. So you can see the diagram. I haven't drawn the line in just yet, but that's where it would be more or less. Okay, so looking good. So that's the equation, guys. And you can see through the help of your calculator, it's actually very straightforward. You've just got to remember the sequence of keys. Okay. Right, so determine the equation of the line of regression. We've done that. And now they're asking us to draw the regression line on our scatter plot. Okay, so plotting a line of a gradient of 0,8571, it's a little bit tricky. All right, so what you need to do is this. There's another point that you need to find, and we call it your mean point. Okay, the mean point is literally the average of your x values and the average of the y values as an x and a y coordinate. Okay, so back out with our calculator. Okay, we're going to clear everything off. I just want to move my calculator back up again. And right, so here we're looking at so let's just go back to the beginning. So that's your original screen that we're on. We're looking for the average. So again, we're going to say mode, and we're going to say 2 for stats. Okay, this time we're looking at just the x value. So I'm going to press number 1, and that brings up a column of just x values. So typing in those, we had 20, 40, 60, 80, 100, 120, and 140. Okay, we press equals. Again, we press AC, shift 1. And again, it brings up a whole list of variables or things that we need to work out. The one we are interested in here is 4 for variance. And can you see the X bar, which is a symbol for your mean for number 2? So let's press number 2 equals. And I'm getting 80 as my mean for X. So my X bar is 80. Let's work out what the y bar is. Okay, so let's clear everything up. Clear it. Okay, we're still on stats, so we can leave it there. We are going to say, so mode stat 1. Okay, this time we're looking at the list of variables. So I've got 6, I've got 16, 30, 48, 70, 80, 80, and 110 equals AC, shift 1, 4 for variance, 2 for mean, and we're getting 51.428. So let's say 51 point, so 51.4, let's just average, round it off. Okay, so on our graph, we're going to plot that as our mean point. Okay, so 80 and 51.4. 80 and 51.4, 51.4, I'm going to have to just estimate, okay, 51.4 and 80. So we're about here, guys. That's your mean point over there. And the y-intercept, now if I were to continue down the y-axis, if that was negative 10, if that was negative 20, negative 17 point, what was our gradient again? Negative 17.14. It's an estimate of around about negative 17.14. So that's my y-intercept over there. So to sketch this line of regression, we essentially have to make sure it passes through the y-intercept and through your mean point, okay? And that will give you your line of regression. Okay, and remember that that line of regression is just a formula that represents the relationship now as best as possible. Remember, it's not an exact line, okay? So it's just a representation of the relationship with as little variation or as little error as possible, as much as we can get down, eliminate as possible. That's our line of regression over there, okay? And last question is then asking us, okay, so we've drawn the regression line, done, okay. Use our line to estimate the braking distance at a speed of 150 kilometers per hour and then 130. Now, okay, this is where we talk about interpolation and extrapolation, okay? If I'm looking for a distance of 130 kilometers, well, 130 kilometers, that's within my data range, okay? So I'm going to, by finding the distance over there, that's interpolation because it's still within my diagram. I can still look at it and I can work out an estimate of what it's going to be. 150 kilometers is no longer within my data set. I'm having to look past my data set and I'm going to have to predict using the formula that I've now got what my answer would be. So I'm going to extrapolate the answer, okay? All right, so the best way to do this is in fact to now use the formula that we have that represents our line of best fit. So our formula, let's do it over here. Here's our formula that represents our line of best fit, okay? And the first distance, what we're going to do is we're going to take our x and we're going to replace it. So let's clear our calculator. Let's go back to 1 there. And we're just going to substitute it in. So I've got 0.8571. But now instead of x, I'm going to replace it with 130. Minus the 17.1428. And what is that giving me? A 94.28. Okay, so let's round it up to the nearest whole. So let's say we have to leave a distance of 94 meters if we're traveling at a distance of 130 kilometers per hour. Okay, which if you were to actually look on your scatter plot, you would be able to see that answer. However, obviously using the formula is that much more accurate. Okay, and then 150 kilometers. Well, guys, all you have to do is just go back in your formula. So just backtrack here. Sorry, not so far actually. And we're going to delete the 130 and replace it with 150 and equals. So again, rounding up to the nearest whole, 111 meters would be what's necessary in terms of a braking distance if you were traveling at 150 kilometers per hour. And the idea here is that if you wanted to now, let's take it to the extreme. If not that we would be traveling this fast, but if you wanted to go 200 kilometers an hour, then you could, by using this formula, determine your braking speed, your braking distance that you would need in order to actually safely brake in that situation over there. All right, so I hope you guys got all of that. I'm going to do another example with you shortly, but I think we're going to take another short break. And when we come back, we'll have a look at correlation coefficients.
All right. Mindsetters, congratulations goes out to Honda Sibasha. You have on yourself this Casio calculator. If you want to be like Honda, all the information about the Test Yourself competition is on our Facebook page. So let's take a very quick break and we'll see you straight after this. Welcome back, Mindsetters. From that break, we are doing our final 2 draws for the Get Connected competition for today. So, Tamerlane.
Right.
Who's feeling lucky? Let's see who's going to win the first one. Ooh.
There we go.
All right. Koketso Tibakwane, you have won yourself 55 Rand Vodacom airtime from the Get Connected competition.
Well done.
Let's shake one more time. And then...
Oh.
Ooh! So many names to choose from,
good.
guys. Yes.
Okay, right.
Tebo Homakalemele, you have won yourself Vodacom airtime as well. Congratulations, guys. Your airtime will be sent to you shortly.
Well done. Okay, guys. Right, so we've had a look at how we calculate your line of regression, okay, using your calculator. We've spoken about the scatter plots. We've spoken about your mean point, okay? Remember, you have to have that mean point together with the y-intercept of your straight line graph to draw that line of best fit. Okay, let's quickly talk about correlation coefficients. Okay, the table below records the results of a study investigating how the number of times exercised per week reduces the number of stress-related headaches. Those of you who are studying for exams, I'm sure you well understand this scenario over here. And we want to see, is there a correlation? Is there some kind of relationship between exercising and getting less headaches, or does exercising give you more headaches? What is the situation here? So let's look at the information. All right, so we've got number of days exercised, which is on our right-hand side, and we've got our left-hand column, which is our number of headaches. And basically, the question is asking for the correlation coefficient, okay? Now, grade 12s, the correlation coefficient is always going to be shown or represented with the symbol of R, okay? And again, we can do this on our calculator, okay? There is a formula, guys. If you don't have the calculator, it can be done by means of a formula. It is a very tedious and quite a long process, but having said that, it can be done, okay? So the answer, if you don't have a calculator such as this, is yeah, then you can do it on using the formula. Okay, back in the day, we didn't always have this calculator, so it was done in that way. All right, so let's type in our information. So back to, ooh, this is, okay, I'm going to have to move that over there. All right, so let's clear up our calculator. Let's go to stat again. And we are going to our number 2 again, and we are going to type in the 2 sets of data. So we've got our 1, we've got our 2, 3, 4, 5, 6. Okay. Just moving over on the other column, or in the other column. All right, we've got our 20, 15, 12, 8, 3, 1 equals. Okay. AC, shift 1, all right. 5 for regression. Okay, so it's a similar, well, in fact, exactly the same sequence of keys that you're working with as you would to find your equation, but this is where it's different. Instead of pressing the 1 and the 2 for the value of your A and your B, you're going to be pressing 3 for the R, for the correlation coefficient. And we're getting a negative 0.995. Okay, now based on what I spoke about earlier with that range of values, do you guys agree that that negative 0.995 is exceptionally close to a value of negative 1, okay? And remember, a perfect negative 1 answer would mean a perfectly negative correlation that the more of one, the less of another, okay? Now, there is obviously slight variation here. There's obviously the odd person who exercises and who still gets headaches. But for the most part, the more we exercise, okay, the more we exercise, and let's just quickly fill that in, 0.995, okay? So that's the correlation coefficient, which means that what we can state about that is that there is a very strong negative correlation, okay? Which implies that the more of your one, the less of the other. So the more you exercise, the less you should have these stress headaches. Okay, so there we go. That's how we calculate the correlation coefficient, which will always be between your positive 1 through to your negative 1. The closer you get to positive 1, the stronger your correlation, that the more of one, the more of the other. The closer you moved on your scale towards negative 1, the more of one, the less of the other. That's your negative correlation. Okay. naught, or anything kind of hovering around the value of naught, is saying that there's really no correlation there, okay? The more you study, the more chance that the Springboks are going to win on the rugby game on Saturday. That will probably come up as a 0 or very much close to a 0 correlation, okay? Okie dokes. Let's have a look at another example quickly, and then we'll take a look at our challenge question. Right, during the Gauteng winter, we all know about that, during the month of July, a number of patients visited a local hospital suffering from influenza. The table below shows the number of patients that were treated. Okay, so dates in the month of July, 4th of July, 6th of July, 10th of July, and so on. And below are the number of patients that were treated for flu. Okay. Draw the scatter plot of the above data. Okay, guys, in terms of our time restrictions, I'm not going to do that right now because otherwise we're going to take up a little bit too much time and I won't finish it. But what we know is, remember, the independent x value is your horizontal axis, your vertical y-axis is your second column. Don't forget to label your x and your y-axis. It is important that those get labeled, okay? From there, all right, so if you've drawn it or if you're busy drawing it, you should start seeing some kind of correlation in your scatter plot. But let's actually work out that line of regression, okay? So again, out comes the calculator and we need to put in our points. Okay, so mode. I need to go, sorry guys. Oh, and I've just closed my calculator. Okay. Should I take a quick break and I can get it back? Is that possible, or should I just carry on? Okay, so I'll let you guys do that. Quickly put in the points in your calculator, and what you should be finding is, now that I've gone and closed it, that we should be getting you press number 2 for stats, then you press number 2, which is your A plus BX button, okay? You're bringing up your X and your Y columns, and you are going to type in all your values for X. Okay, so each one, and then you follow it by an equals, and you put in the next value, and you follow it by an equals, and you get all the X values.
Tamerlane?
Then you type in your Y's.
Take a break.
Shall we do that? Okay,
Yes.
I think it'll be easier. Guys, let me get that calculator back, and I'll be with you in a minute.
All right, Mindsetters, let's take a very quick break, and we'll see you straight after this. Welcome back, Mindsetters. Just a reminder about the Get Connected competition. If you entered last week, all you need to do this week is ask all your friends to share the post and to like the picture of your favorite teacher. So you don't need to go through the whole curio thing, entering the learn and picking your favorite teacher. Just ask all your friends to share the post and to like the favorite teacher that you've chosen. Another thing, please go play the essay water game on www.watergame.co.za. Teaches you more about water conservation and what you think about water issues. All the information is on our Facebook page, so go check it out and start playing, guys.
Okay, right, we're back. Calculator in hand. So, all right, so I've typed in all the values, which I'm hoping you guys have done as well. And remember now what we do is we say AC, we say shift 1, 5 for regression, and 1 for our A value, which is giving us 118.6. So A is 118.6. And the B, okay, so to go back to the B, don't go and re-enter all the values. We just, again, press AC, shift 1, 5, and this time we press 2. And that's giving us 28 point, let's round it up to 28.4. Okay, 28.4. Just be reminded that the formula that they gave us in or on the calculator was in the form of A plus BX. So therefore, our equation is Y equals 28, 4x plus the y-intercept of 118.6. Okay, and that, guys, remember, is the equation that represents your line of best fit. Okay, for question number 3, it says draw the line of best fit. Okay, so remember what you need in order to draw that is the y-intercept. So you need that 118.6 as the y-intercept of your straight line graph. And the other thing that you remember you need to have is your mean point. So you take the average of your x values and the average of the y values as the other point that you will draw your straight line through. Okay, so it's quite simple to draw your straight line graph. You don't need to worry about the gradient or anything like that. It's just the y-intercept and your mean point. Okay. Right, once you have drawn that, the question is asking us to estimate how many patients were treated as at the 28th of July. Is that interpolation or extrapolation? Well, the 28th of July is beyond the dates that we actually have in our data set, so we're going to extrapolate that answer by means of using our formula. Okay, we're going to clear that up and we're going to say our formula was 28.4, but now instead of x, we're looking for the date of the 28th. Okay, so x is 28 plus 118.6, and that's giving us now 913. So as the dates in July are getting further and further on, so the number of people who are suffering from flu is getting higher and higher. So there's a positive correlation over there. The next date we were looking for was the next date. Okay, let's have a look at the 31st of July. And I'm sure you guys will agree that by looking at our trend, we're guessing that it's going to actually be quite a lot more. But let's quickly see. I'm going to just move backwards, just go back through my points, and I'm going to place 31st of July. So yes, 999 people are now being treated for flu. Okay, so we've got a linear relationship. It's the more of one, the more of the other. And in terms of, now let's see how close is this correlation. We want to determine, is it a moderate correlation? Is there some kind of relationship between the weather getting colder and more people getting flu? Or is there quite a strong correlation between the two? So we go back to our calculator and we press AC Shift 1. Okay, now remember, we've already entered all of this data, so you don't have to go do it again. We just press 5, but this time, remember, the button we're looking for is 3. And it's an even stronger correlation than the one we had in the previous example. If I've got 0.9882, well, we can state there that we have got a very strong positive correlation between the weather and people getting flu. Okay, hopefully with spring on its way, that's going to come to an end. All right, guys. Okay, so now let's quickly go back to this challenge question. Okay, I'm sure that a lot of the concepts that we spoke about in the beginning of the lesson might have sounded very foreign and might not have been very clear, but hopefully now that we've actually worked through it, we'll be able to actually get the concept quite easily. Okay, remember the question was, we were looking at the age of customers and the amount of money that they were spending in rands on shoes. Okay, so the first question asked us to use our calculator to determine the line of regression, which is the line of best fit of the given data. Okay, so what did we do? We took out our calculators and you're going to enter all of that data. Okay, and you're working out your A value and your B value. All right, grade 12s, in terms of time, I'm not going to be able to type all of this into the calculator here. Please go to the notes on the website and just double check the answers. They're all there for you. Okay, so using exactly the same process that I've done in the previous examples, that's what you need to do to find your A and your B and get your equation. Determine the correlation coefficients. Okay, so what is the correlation? Is it very strongly based on the older you are, the less money you spend on your shoes? Just looking at the data that we've got here, it would appear that that's the case. As these people are getting older and older, so the amount of money that they're spending on their shoes is getting less. So I'm sure that there are a few outliers there, though. I'm sure that that's not completely accurate. Hey, Luni, do you agree? Okay, so we were going to have possibly a negative correlation. So your scatter plot is going to have your dots going from high up and then actually going down, further down as you're going from left to right. So as the one increases, so the other is decreasing. And you worked out your correlation coefficient on your calculator to get your value of R. All right? And once you have done that, predict how much money a 16-year-old will spend on shoes at the store Okay, do you guys agree again that would be an example of extrapolation? All right, because it's not 16 years old, is not within the range of data that we have over here. We're from 18 to 45. But because we have that formula, all we have to do is substitute 16 into the x of your equation, and you will get your answer. Okay, an estimate answer, but a very close estimate. And whether the prediction of the question is reliable. So what you're looking out for over there, guys, is outliers. Okay, you want to check, is there anything, if there is an outlier, all right, and you're working and you're trying to work out a line of best fit, you need to exclude that outlier, okay? Because if you include it, it's going to actually make your line of best fit shift it up or pull it down, and it's actually going to make it an inaccurate reflection of the situation. So just watch out for that. An outlier might not make the prediction accurate. So other than that, it's a very, very close prediction of the answer. I hope you guys understood all of that. Go and practice that on your calculator, and I hope that this is a great section in your exam.
Thank you so much, Tamerlane, for the lesson. Mindsetters at home, thank you so much for tuning in. Until next time, we didn't get through all your questions. Learn.mindset.co.za/helpdesk. Send your questions through there from us. Goodbye, guys. What's up, Mindsetters? Welcome to your grade 12 maths lesson on a Monday. I am Luni, and with me is Tamerlane.
Hi, guys. How are you?
We're good. How are you doing, Tamerlane?
Very, very well today. Thanks so much.
All right. What are we doing for the matrics today?
Today we are doing statistics, which is a section which has a lot of carry through from grade 11 and even grade 10. But what's really interesting about stats in grade 12 this year is there's quite a lot of new stuff that they've added to the syllabus with regards to lines of regression and correlation coefficients, and they all sound very interesting, but they're actually quite easy to work out.
All right, Mindsetters, I hope you guys are excited for the lesson and will be tuned in. Just to tell you about a competition we have running, it's called Get Connected. All you need to do is go to our Facebook page. All the information is there, but I'll take you step by step through what you need to do in order to stand a chance to win either Vodacom Airtime or a Sony Xperia L. So you go to our Facebook page. There's a link there with capital letters Learn. What you do is you click on that link. It will take you to a Curo page. You enter the Learn code, and then you pick your favorite teacher. The various teachers there, you pick your favorite teacher. After you've done that, you go back to our Facebook page. There are links with the teacher's name. So if you chose Camelin, you go to /Camelin. You click on that link. It will take you to a picture of that teacher. You like that picture. And then once you've liked that picture, you go back to the graphic with all the information about the competition, and you share that post. Once you've done that, you'll stand a chance to win airtime. All the people who've shared the post will stand a chance to win airtime. All the people who've liked the teacher with the most likes will be sent through a lucky draw to stand a chance to win a Sony Xperia L. Right now, we are going to do a lucky draw for the winner for the airtime. Tamerlane, are you
Wow,
ready?
that's exciting.
Okay, so I'm going to shake.
To look at these new concepts, which are scatter plots, lines of best fit, which is just another word for the line of regression, something called interpolation and extrapolation, and correlation coefficients. Now, I know that possibly all those words look quite large and a little bit daunting at the moment, but with explanation, I'm sure you're going to understand them perfectly fine. And then lastly, obviously, our examples that we're going to do to explain and obviously just clarify all of those concepts for you. Okay, so we've got a challenge question, which without having done the exercises just yet might look a little bit strange, but I want you to take it down. I want you to take note of it. And as we're going through the exercises, see if you can then actually give this a go, and at the end we'll have a see in how you manage, okay? We've got a men's shoe store conducts a survey from a representative sample of regular customers to see ages of customers against the amount they spend monthly on shoes. Okay, so we've got this table. So very quickly, age of customer, if I've got 18 years old, they're spending about 330 Rand on shoes, 21 years old, 300 Rand on shoes, and so on, okay. First things you're going to do is you're going to use your calculator to determine the regression line which best fits the given data. Okay, so take notes of that, guys, because I'm going to teach you how to do that shortly, is how to find that equation that represents the line of best fit, okay? Once we've done that, we're going to determine the correlation coefficient for the data set. Okay, now again, I know that that sounds a little bit of a daunting phrase at the moment, correlation coefficient. Remember the word correlation. If anything at the moment, think about what I'm talking about when I talk about correlation. How are they related to each other? Are they closely related? As one of them increases, does the other one increase? Remember that that represents a positive correlation.
Sparks. Okay.
No, not to look. There we go.
Important. See, you have won yourself Verticum airtime.
That's awesome. Well done.
Simple as that. Mindset is all I'm here. Facebook.com/LearnExtra is our Facebook page. @LearnExtra is our Twitter handle. And you can get all the videos, the show notes, and the schedules on learn.mindset.co.za. Tamilene.
Thank you so much. All right, guys, so let's get going with our stats. If you guys haven't started with stats in school yet, you're going to be doing it very soon. And as I said, a section which has a lot of carry through from grade 10 and 11 work. So you do need to get out those old books. You do need to study all of that theory. And then obviously we're going to add to it today with our regression and correlations. Okay. All right, guys, so let's just very quickly look at what we're doing today. We're going to first just have a look at those grade 11 concepts. I'm not going to spend too much time in terms of actually teaching it, but we will discuss it briefly. And then we're going to